All right, we're back here for 11.4. This is your professor, Mr. Boone, going back again. Today we're going to talk about compound events. And again, compound event is where you have more than one, two or more typically. And we're going to talk a little bit about mutually exclusive. Now these are things that can't happen at the same time. So if we look at our Venn diagram, event A, B, there's no overlap, okay? So when I roll a die, I can't roll a 2 and a 3 at the same time. I either have to roll a 2 or have to roll a 3. Those are what we call mutually exclusive because they cannot occur at the same time. All right, so again, there's a little picture on that. Now, how do you find the probability? Now, we just talked in 11.3 on independent and dependent events where we multiply those events. Well, if we have two mutually exclusive events, what we're going to do to happen, now again, look at the notation here, little set notation here with, this means or. Okay, or is with the U here, and is going to be the upside down. We'll see that in just a second. But if the events are mutually exclusive, the events that A or B happens is you just add the two probabilities. So again, if I try to roll a 1 or a 2, well, the probability of rolling a 1 is 1/6. Probability of rolling a 2 is 1/6. So the probability of rolling 1 or 2 is, add them together, 2/6 or 1/3. So remember again, that symbol means or. If it's upside down, it will be and. We'll see that here in just a second. All right. So again, I have some things asking you about if things are mutually exclusive. So it talks about a student that has type O and another one that has type A blood. They're mutually exclusive because you can only have one type. You can't have both. Okay, you have one or the other, and that's why they're mutually exclusive. If you were to find the probability, you would add their probabilities together. Okay, same kind of thing here when you're voting. 25% voted for Hunt, 20% voted for Klein, 55% voted for Vila. Now again, why are those events who you voted for independent? Because you can only vote for one. You can vote for 2 or 3. You can only vote for one, and that's why they're mutually exclusive. So if you wanted to find the probability of voting for Hunt or Klein, you would just simply add their percentages together, is what you would do. All right, so what happens if they're not mutually exclusive? Okay, so we call those inclusive events where you could have some overlap here. Like if I'm trying to find even numbers on a die, that'd be 2, 4, and 6. And then if we had prime numbers on a die, remember prime numbers are divisible by 1 in itself. Well, 2 is the only even prime number, by the way. And then 3 and 5. So you can see that 2 is shared. So when you're finding the probability, you can't count that twice. So we're still going to find the probability of A or B by adding the 2. But then what we have to do is subtract out the overlap. So here's what it looks like in the formula. Right here, and again, this symbol means or, this one means and. So if they're inclusive, you're going to take the probability of A plus B. You're going to subtract out the probability that it's both, okay, that it's both of them. All right, so again, looking at our example, there's 3 out of 6 numbers on a die that are even. There's 3 out of 6 that are prime, but again, we've counted that 2 twice. Remember that it's both prime and even. That's the 1 out of 6. That's the number 2, so that's why we subtract that out so that we don't count it twice. All right, so let's look at an example here. Find the probability of rolling a 4 or an even number. Now the probability of rolling a 4 is 1 out of 6. And probability of rolling an even number is 3 out of 6. All right, but remember, 4 is also an even number, so we have to subtract out the probability that it's both, which is 1 out of 6. So once again, our probability is going to be 3 out of 6 or 1/2 is what we do there. Now again, some of those things that you can do too is if you want to, you just go ahead and line up the numbers on a die, 1, 2, 3, 4, 5, 6. All right, so rolling a 4, just cross that off, and then an even number, well, 4 is already crossed off, 6, so you can kind of do it that way. If it's a small sample space, you can actually write them out and then circle or cross off the ones that fit the categories, and then obviously don't cross off the same number twice. That's a good way of doing it too, if you don't have a very large sample space. Okay, so a couple different ways of thinking about it. All right, how about this one? What's the probability on a number cube rolling an odd number? All right, so rolling an odd number would be, again, 3 out of 6. And then a number greater than 2, so that'd be 3, 4, 5, 6, so that would be 4 out of 6. Well, we already know right now there's going to be some overlap because we'd have 7 out of 6, which we know can't happen. The highest probability you get is 1. So we got to subtract out the odd numbers that are greater than 2, so that's 3 and 5, so that's 2 out of 6. So if we did those, our probability would be 5 out of 6. Now once again, small sample space, just do 1, 2, 3, 4, 5, 6. Okay, cross off your odd numbers, 1, 3, 5. or a number greater than 2, well, there's 4 and 6, the ones we haven't crossed off. Well, yeah, that's 5 out of the 6 numbers that we have. So a couple different ways of doing inclusive when there's some overlap in those numbers. Okay. Well, that should get you going. 11-4. We'll do the worksheet, check the key. Like I said, come back and see me on these questions. Now, again, after 11-4 now, go back, review those things again. We'll have the Google Forms quiz out and available to you. Remember that you're going to get 60% on that quiz. If you don't, you get to redo it, and you got to keep doing it until you get that 60%. And we'll let you know how you do on those and keep track of that. So, all right, good luck on that and the quiz. Like I said, email me if you have some questions. We'll be back next time for 11-5. See you next time.